Assalamu alaikum and salamat pagi. For today's class, I will give a lecture on Chapter 2, Basic Cryptography. Before we go deeper into the topic, it is best to know the definition of certain words in cryptography. Cryptography is the science or art of encryption, while cryptanalysis is the science or art of breaking an encryption. Cryptology is the combination of both cryptography and cryptanalysis. Cryptography has two goals. First is to prevent someone from intercepting a message. Second is to prevent someone from impersonating the sender of the message. Most of the web browsers nowadays have built-in encryption for data transfer, especially for e-commerce applications. Cipher can be interpreted as a secret or disguised way of writing or a code. Plaintext or data transferred can be encrypted through bitstream or block cipher methods. Bitstream cipher transformed plaintext bit into cipher bit 1 bit at a time. While for block cipher, message is divided into blocks of 8-bit or 16-bit and then transformed to block cipher. The diagram shows the cryptosystem. Cryptosystem is the system of cryptography which consists of algorithms, data handling techniques and procedures. Listed a few examples of data handling technique, or we call it encrypt and decrypt. Substitution cipher, substitute value from another. It can be divided into two categories, monoalphabetic substitution and polyalphabetic substitution. The diagram shows the monoalphabetic substitution. Each alphabet is substituted or represented with another alphabet. Vigenere cipher is an advanced cipher type that uses simple polyalphabetic code made up of 26 distinct cipher alphabets. The diagram shows how Vigenere cipher works. The diagram shows a simple encryption method using exclusive OR, a function of Boolean algebra. This method is also called bitstream cipher. Cryptographic algorithms are the keys used in encryption and decryption. The algorithms can be categorized into symmetric and asymmetric algorithms. Those algorithms are distinguished by types of keys used for encryption and decryption operations. Symmetric encryption uses the same secret key to encipher and decipher messages. Both sender and receiver must possess encryption keys.
Tom is sending a lovely message to Mary, and he doesn't want anyone else to see it. He wants both romance and privacy. He wants to encrypt his message. Well, that's easy because Tom shares the same key with Mary. They will use the same key during the encryption and decryption of the data. Here is how it works. First, Tom uses his key to encrypt his message. Now his message is encrypted to scrambled data. No one can read it. When Mary gets the encrypted message, she uses the same key to decrypt his message so she can read it in plain text.
Data encryption standard DES is one of most popular symmetric encryption cryptosystems with 64-bit block size and 56-bit key. Asymmetric encryption uses two different but related keys. Either key can encrypt or decrypt messages. Those keys are public key and private key. Usually, a private key is used for decryption.
Tom is sending a lovely message to Mary, and they agree to use the public key encryption to encrypt his message. Remember, public key encryption to encrypt the sender's message starts with the receiver, Mary. Here is how it works. First, Mary creates a pair of keys, one public key and one private key. She keeps a private key and gives the public key to Tom. After Tom writes his message, he uses his public key to encrypt it. When Mary gets the encrypted document, she uses the private key to decrypt it. Remember, the public key method to encrypt the sender's message starts with the receiver, not the sender. The public key is public to everyone. The private key is only known to the receiver.
The size of key is important. Strength of many encryption applications and cryptosystems measured by key size. For cryptosystems, security of encrypted data is not dependent on keeping encryption algorithms secret. Cryptosystem security depends on keeping some or all of elements of crypto variables or keys secret. Using digital signatures, encrypted messages that can be mathematically proven to be authentic.
A digital signature is equivalent to a handwritten signature. It is an electronic verification of the sender. Let me demonstrate how digital signature works. Here is the scenario. Bob is sending a memo to Alice with his digital signature. Keep in mind, digital signature uses a symmetric cryptography, which means public key algorithm is employed. First, Bob generates two keys, public key and a private key. Bob keeps the private key and gives Alice, the receiver, the public key. After creating a memo, Bob generates a digest by hashing his memo using some hash algorithm. Bob then encrypts the digest with his private key. This encrypted digest is the digital signature for the memo. Bob sends both the memo and the digital signature to Alice. Notice here, the memo is not encrypted. We only focus on digital signature. When Alice receives them, she will do two things. One, Alice decrypts the digital signature using Bob's public key and she gets the digest. If she cannot decrypt the digital signature, then she knows it did not come from Bob because only Bob's public key is able to decrypt the digest generated with his private key. 2. Once Alice gets the digest, she will check the integrity of the memo. Here is what she does. Alice hashes the memo with the same hash algorithm Bob used and compares the result to the digest she received. If they are equal, Alice can be confident that the memo has not changed since Bob signed the memo. If the digests are not equal, Alice will know the memo has changed in transit.
Hash algorithm is a one-way transformation generating message digests. This is the list of standards used for hash algorithms. SHA 256 or Secure Hash Algorithm 256 is the common hash algorithm used nowadays.
Hash algorithm is commonly used for passwords. Take Twitter as an example. Today I want to see what's going on with Donald Trump. I needed to log in first. My username, Sunny Song, my password, ABC123. When I click submit, both my username and password would be sent to Twitter database. But before my password is sent to the database, it is hashed to a digest. Let's assume Twitter use SHA-256 as their hash algorithm, then my password digest would be 256-bit long. You might say, hey, your password is too easy, is it too risky? You are right. How about I love you princess? Believe me, it's not a good password either, but for the sake of learning, it's okay at this moment. A new password, a new digest, of course. But The digest size is still 256 bit long. Therefore, the same hash algorithm always produces the same sized digests.
Steganography is a process of hiding information. Most popular modern version hides information within files appearing to contain digital pictures or other images. Cryptographic attacks can be done through ciphertext only where the attacker has only ciphertext, or known plaintext where attacker has plaintext and corresponding ciphertext, or chosen plaintext where the attacker can encrypt messages of his choosing, or distinguishing attack where an attacker can distinguish your cipher from an ideal cipher, random permutation. In a nutshell, a cipher must be secure against all of these attacks. That's all for this chapter, Chapter 2. Next week, we will explore Chapter 3, Security Model. Assalamu alaikum.